So the initial spec was designed to work with a single interface between the chipset CPU and the TPM, but we had 5 or 6 different vendors with 5 or 6 different interfaces. And the real challenge was to converge them into one so that they all worked with a single interface talking back to the chipset and trying to negotiate between all of these vendors who are actually competitors and trying to get them to, and successfully getting them to agree on a common set of interfaces between them, I think was the biggest challenge I had, especially in the very early days. We've settled on that interface now, and but now it's been 25 years. People have matured, but originally they were their own proprietary interfaces that we had to merge into one. And what was amazing was how cooperative everybody was. They were willing to move things around. Yeah, I can move this, I can move that, I can't move this. So then we had to make some compromises, and that's why people look at the interface and go, why is it weird that way? And that's why, because we couldn't get agreement on things like buffer size and things like that. So we had to create a variable buffer size. This is a good example, because some had small, some had large, and they needed to be. So we had to do some things that people look at us and, why'd you do it that way? Well, that's because in the early days we didn't have a choice. So that I think that was the biggest challenge to me, was getting. And what was really interesting is how, and overall, how, and maybe this leads into another question, but what's really interesting about TCPA and now TCG is you have competitors and people who are partners and customers all seeking the same goal, and an incredibly cooperative environment in this way, and that's reflective back in the early infrastructure, the early interface. So besides what I just mentioned, the actual interface itself, I was chair of what's called the PC Client Working Group. The TPM is designed actually to go on any type of platform. The initial platform was the PC client, or as we call it, the Windows system, a Linux system. And we had to define how exactly it fit and what the registers, if you're familiar with TPM, you've got these things called PCRs, platform configuration registers, how they are populated. The boot sequence from the initial boot of a PC when you power it on all the way up to the operating system is actually fairly complex. There's lots of different components, and it might be from various vendors, various sources. And we wanted to make sure that in some organized fashion, regardless of the design of the system, whether it be this OEM or that OEM, everything was reflected in the same set of registers, regardless of who it came from. So that's all in the PC client spec, and how that interfaces with not just the BIOS, which is the firmware, the early boot firmware, but it also how the operating system itself interacts with it. So that was my first and earliest contribution to Trusted Computing Group. We wanted to build a very open environment. There were lots of, and there were, and continue today, proprietary solutions that offer similar use cases and solutions. But what we wanted was to have something that any platform, including the aforementioned Windows system or Linux-based system, what we think of as a PC, but we also wanted to develop something that would go cross-platform into networking equipment, into servers, into industrial systems. And we would have a common set of commands so that each one of these systems didn't have to invent their own set of key management, their own set. So we wanted to design an open system that anyone can use, and all the software would be portable across all of these different environments. That was really the initial goal in doing that, to keep it from being proprietary. So that was the motivation behind it, really. There are lots of other motivations, but to me that was the most important, because I believe security should be open. It shouldn't be proprietary.